now let's move on to the next presentation. So this is coming from a material supplier, one of the leading, in fact, world's largest encapsulation supplier, HANGZHOU FIRST. We have Bojin, who is an overseas sales manager at HANGZHOU FIRST. He is going to talk about high quality encapsulation solutions for high efficiency TOPCon PV modules. Bojin?
Yeah, thank you. Thank you for your introduction. So hopefully you can hear my voice, and let me share my screen. Okay, thank you. So my name is Bo, and I am from HANGZHOU FIRST, and we are the encapsulant and the backsheet manufacturer. And I would do some introduction about the high quality encapsulation solutions for the high efficiency TOPCon PV modules. So my presentation is with 4 parts. The first part is the failure modes of TOPCon module, and the second part is the anti-PID and anti-collision encapsulation solutions for TOPCon, and the third part is the UVID solutions for the TOPCon module, and the last part is the short summary. So at the moment, the TOPCon is dominating in the market, and for the TOPCon modules, the market needs higher efficiency TOPCon modules, TOPCon cells, and from the technology perspective, it is still developing, and it also needs better encapsulation solutions for the reliability. So there are failure modes, which we often see, for example, like UV lights, heat, humid, acid, bias voltage, etc. So we can say that among these kind of failure modes, there are 3 main groups. One is the damp heat collision, and the second one is the PID, and the third one is the UVID. So for the damp heat collision and the PID issues, I put them together in the same part. So for these 2 situations, we have some suggestions for the encapsulation. So firstly, let's say the glass TOPCon and glass-backsheet TOPCon module encapsulation. So when we see the glass-to-glass TOPCon modules, high reliability combination for the encapsulation is using POE or EP on the front, and on the back side, it can be either POE, EP, or EVA. And when it is cost-effective solution, then we recommend to use anti-acid EVA on both sides. And when it is about the glass-to-backsheet TOPCon module, we suggest to use the special POE from our company to use TF4N as high reliability solution. And on the back side, you can use either white EVA or anti-acid EVA. As a cost-effective solution, the front side can be replaced with anti-acid EP material. So let's talk about the glass-to-glass TOPCon module. So you can see the PID test result when it is used the POE or EVA, EP on the front side. The anti-PID properties are pretty good, and when you use the cost-effective solution to use anti-acid EVA S406P on both sides, you can see that after the UV recovery, the PID is still under the control. But when you use the normal EVA as the encapsulation, then you can see the power loss even after PID 96. And when it is about the damp heat aging test result, again, when you use POE or EP on the front, then the power loss is less than 5% after DH 3000 hours. And when it is using the anti-acid EVA S406 on both sides until DH 2000, it can behave good And you can see that from the EL pictures on the right side, the DH corrosion can be explained as the paste corrosion on the edges. And also the EVA emits acid, and this kind of acid environment inside module can also contribute to the corrosion. So since we talked about the paste, we also did the TOPCon module test with different paste material, paste A, paste B, and paste C. So you can see that by using different paste, the result is also very different. When we use paste B, the PCT test result shows the worst scenario. So in our opinion, the paste have very decisive impact on the corrosion of the resistance TOPCon cell, and the suitable paste needs to be selected. And now we switch to glass-backsheet TOPCon module. Again, we start with the PID test. So when we use the special POE TF4N on the front side, the result is good. And when we use the anti-acid EPE, EP304S on the front, the result, it is also proper, but of course slightly not as good as using TF4N on the front side. And when we test the damage test for the glass-backsheet TOPCon module, you can see that when we use the TF4N, it brings low WVTR property, and also it brings the electrochemical reaction blocking function, so it can protect the TOPCon cell well. So until DH3000, it can have less than 5% of the power loss. And when we use anti-acid EVA on the front side, after DH2000 hours, after DH1500 hours, it can slightly pass 5% of power loss. And also it depends on the cell as well. So when we choose different two type of TOPCon cell, cell A and cell B, we can see different behavior of the anti-corrosion property as well. So it's quite important to choose proper cell for the glass to backsheet TOPCon module. So for the glass backsheet TOPCon, the backsheet, it is also one factor for the reliability. And we also tested, compared the standard backsheet and also low WVTR backsheet. And we used anti-acid EVA on the front side and white EVA on the back side for this comparison test. And we see that when we use standard backsheet and the low WVTR backsheet, the damage test result is somehow shows very, how to say that, unexpected result. So when we use the standard backsheet, the CPC backsheet, the result is better. So we consider if the low WVTR backsheet, which is not the aluminum backsheet, it can also not contribute too much to the damage aging properties for the TOPCon module. But maybe if you really want to use the low WVTR backsheet, then maybe the aluminum backsheet can be the right option. And then we switch to the part 3. So for the UVID solutions for the TOPCon module. The TOPCon cell, it also be afraid of the UV lights. The passivation layer can be decomposed by the UV radiation. For this kind of situation, we have two solutions. One is to cut off the UV, and the other one is to convert the UV. the UV cutoff solution is to use the UV cutoff film on the front side of the TOPCon module. But if you use the standard UV cutoff film, then the power loss is too much. So we have a special UV cutoff version, which cutting off from the 320 nanometer. And it is like a good trade-off. The power loss is minor, and also it can protect the TOPCon cell well from the front side. And you can see that the how to say that the wavelength, which is higher than 345 nanometer, the transmittance can reach more than 91%. And the main absorption happens around 305 nanometer. And when we do the DH aging and UV aging, we also see that the film has good anti-discoloration behavior. And when we talk about the UV down conversion, it is the technology to convert UV light into visible light. And the UV light absorption happens between 320 nanometer and 380 nanometer, and it emits the light, and the emission maximum wavelength is around 425 nanometer, which is the blue light. So visually, the module looks a bit bluish. And here we conducted the UV durability test, and we can see that the down conversion film from our company can be well controlled under the high UV radiation. After UV 600, the UV conversion film at the 365 nanometer is still less than 3%. And also we conducted the heating test as well. So after the heating, the discoloration is under the control, and also the down conversion function is still working well. Also, we tried different concentration of the fluorescence molecules, which is the dosage of the down conversion additives. And we tried 3 different dosages, and you can see that the initial power loss is less than 1 watt, and it can meet the requirement of the power loss is less than 1% after UV60. So to summarize my presentation, for glass-to-glass TOPCon, of course, when you choose the premium encapsulation solution, we suggest to use POE or EP on the front side. And if you choose a cost-effective solution, then both side anti-acid EVA can be the choice. And for the glass backsheet TOPCon modules, we suggest to use special POE TF4N on the front side, and the normal backsheet can be used, and on the back side, either white EVA or low acid EVA can be used. And for the UVID issues, we suggest either to use UV cutoff film on the front side or UV conversion film on the front side. Thank you.
Thank you, Bo. I think that was very nice presentation explaining the UV degradation part. So, you also mentioned in your presentation that the paste has an impact, and then the cell type also has an impact on the encapsulation. But I think maybe this is very much directed towards the integrated manufacturers. Of course, PV is also getting more and more integrated, but still there is a lot of only module capacity out there. So for them, what do you recommend? Because, probably they don't have the control about the metallization pace. So in such cases, how a only module maker should go for the encapsulation to be on safe side?
Yeah, for the safe side, of course, we suggest to use POE. And from the cost perspective, I think the manufacturers also care a lot about the cost.
Sure.
And we see the price gap between POE and EVA is getting smaller and smaller. So POE has good anti-PID properties and also low WVTR properties. And yeah, using POE is the good option if you want to have better results, no matter what kind of TOPCon cell you choose.
Okay, thanks a
Yeah.
lot. I think there are also a few questions in the chat window. Please, enjoy our conference while answering these questions. And I would like to move on to the next presentation. Thanks a lot.
Bye-bye.
Okay.